Hi students, in this session we are going to focus on rules for tracing images formed by spherical mirrors. Otherwise guys, we can also call this as the rules for drawing a ray diagram in the process of image tracing, right? For spherical mirrors means convex and concave mirror. As a part of that guys, if you consider the rule 1, then when the incident light is falling parallel to the principal axis, listen guys, here this is parallel to the principal axis and this is the concave mirror. Fine. Then after reflection, the light ray passes through the focus, and this is a standard rule and a very important rule guys. We will use quite often in image formation. Okay. So for concave mirror guys, when the light ray falls parallel to the principal axis, then after reflection, all the time it passes through the focus. IL for incident light I am taking, RL as reflected light I am taking. And at the point of incidence, let X is a point of incidence. Friends, if you draw one imaginary normal, then this normal will meet at center of curvature. So this dotted line is the normal guys. And with respect to this dotted line, if you take this as angle of incidence and this as angle of reflection, then I and R must be same students. Here it satisfies the rules of reflection. Similarly, if you take the same thing for convex mirror students, right? Same situation for convex mirror. Just before I explained for concave mirror, if you take the same situation for convex mirror students, then let us consider here you have to take the light reverse guys arrows like this. Okay, this is the situation. If you consider the light ray falling parallel to the principal axis, then after reflection it gets deviated because students convex mirror is treated as diverging mirror. The light ray after reflection get diverged. Concave mirror is converging mirror. The light ray will get converged after reflection. That's why students, here the incident light after falling on the concave mirror gets reflected and converges towards the principal focus. But whereas here not like that, the light ray after falling parallel to the principal axis, it gets diverged. This is the diverged ray or divergent ray. This is the incident light. And here students, if you extend the divergent ray, then it meets at the focus, right? And if you draw imaginary normal at the point of incidence and extend that normal students, then it meets at the center of curvature. Now if you consider this as angle of incidence, right, here the ray diagram is reverse students, better you take this is angle of reflection, then we can write I is equal to R. So the situation is guys, here the light ray is falling parallel to the principal axis and get reflected like this. And if you take imaginary normal at the point of incidence, the normal appears that it is coming from the center of curvature. Every time the same thing happens, and if you take I as the angle of a reflection between incident and the normal and R as angle of reflection, then I and R are always equal. Okay students, so the rule 1 for concave mirror will be like this, and the same rule for convex mirror will be like this. Okay guys, so let us focus on the rule 2, right? If you take the rule 2, then rule 2 is quite opposite to the rule 1. Okay guys, in the rule 2, ray passing through the principal focus of a concave mirror of a ray which is directed toward the principal focus of a convex mirror emerges parallel. That means, let us see guys, just quite opposite to this rule. That means here the incident ray is passing from the focus, students. See, the light ray in the second case passing from the focus. After reflection, it becomes parallel to the principal axis. Whereas in the previous situation, the incident light is passing parallel to the principal axis and after reflection passing through the focus. See, but in the second case, guys, the light ray is passing through the focus and after reflection, it becomes parallel to the principal axis, quite reverse. The same thing for the student. See, exactly here it is given. The incident light is passing parallel to the principal focus. Here you need to change little the right like this. If it is passing through the principal focus, after reflection becoming parallel. Okay, students, this is the rule 2. Rule 2 is quite opposite to the rule 1. It satisfies the principle of reversibility. Okay, guys, rule 1 and rule 2 is the best example for understanding the concept of principle of reversibility. More about this we will study in the refraction through plane surface. Okay, guys. So in the rule 2, students, light ray passing through the focus and falling on the concave mirror, then it gets reflected, becomes parallel to the principal axis. In case of convex mirror, the same rule, guys. If the light ray appears that it can pass through the focus, means like this, see students, it is coming like this, getting reflecting. And if you extend the incident light, then the incident light is going to meet at the focus. This is reflected light is becoming parallel. Now, if you draw the imaginary normal, then all the time imaginary normal at any point on the mirror, it meets at center of curvature. Now, relative to this imaginary normal, if you take I as angle of incidence, R as angle of reflection, so here also the law of reflection I is equal to R must be satisfied, whether it is convex mirror or concave mirror, doesn't matter. Okay, guys. Next, go for rule 3. In the rule 3, students, the light ray passing through center of curvature, after reflection, it retraces the path. See, guys, it is going like this. After reflection, it retraces the path. Here also in case of convex mirror, the same thing, students. The light ray, if it directly falling along the center of curvature, because students, the light ray passing through center of curvature is nothing but it is the normal incidence, right, students? For normal incidence, the reflected ray will retrace the path. It will travel back into the same like same path but opposite direction, like see, incident light and reflected light. So this is incident light, this is reflected light. Here also same thing, incident light and reflected light. This is the rule 3. And in the rule 4, guys, let's consider the light rays passing or the light rays falling at the pole. So when the light ray is directly falling obliquely towards the pole, then it reflects obliquely as per the laws of reflection. That means incident light and reflected light remain symmetrical to the principal axis, right? So this is the principal axis, guys. To the principal axis here, incident light and reflected light will remain symmetrical because I is equal to R. The same thing in case of convex mirror also. This is concave and this is convex. Understood, guys? So listen, before getting into the ray diagrams for image formation of concave mirror and convex mirror, it is compulsory to know the rules for drawing the ray diagram. And these 4 rules are quite standard, okay, guys, for understanding the image formation. So rule 4 is so easy to remember, guys, because it is falling at the pole and reflecting symmetrical to the principal axis in both the cases. And in the rule 3, guys, the light ray passing through the center of curvature getting reflecting along the same direction. And in the rule 2, light ray passing from the focus after reflection getting parallel to the principal axis, right? And in the rule 1, reverse to that. The light ray falling parallel to the principal axis, after that going across the focus. Okay, guys. So here, these 4 rules for convex mirror and concave mirror are very important for understanding the image formation for ray diagram. Okay, guys. Let us see the image formed by the concave mirror now. And in the ray diagrams, we are going to make use of these 4 rules, students. See, in the initial case, in the first case, object is kept at infinity. So when the object is kept at infinity, guys, keep in mind that the light rays from the infinite object always appears to be parallel. I repeat, students, when the object is kept at infinity, then the light rays from the object appears to be parallel. Therefore, if the light rays are coming from infinity, then it appears to be parallel to the principal axis or parallel like this, students. If you consider parallel to the principal axis, then after reflection, obviously, according to the rule 1, they must pass through the focus. Therefore, students, when the object is kept at infinity in case of concave mirror, image forms at focus like this. So I took the point object in this situation, students. Suppose if you take this one, what do you say, guys? Extended object. Usually, For the object at infinity, guys, the image formed will be at the focus, that too very small image, right? And in the second case, guys, if you consider the object beyond C, see, when the object is kept beyond center of curvature, then in this case, if you draw the ray diagram, by taking one light ray parallel to the principal axis and one more light ray passing through the center of curvature. According to the rule, students, this light ray will pass through the focus and this light ray will retrace the path. Now, if you focus on the reflected light rays, both are meeting here. See, the reflected light ray 1 and the reflected light ray 2 are intersecting here, where you will expect the image. Now see guys, in the second rule, when the object is kept beyond C, then image will form between F and C. Okay, between F and C. When the object is at infinity, we got image at focus. No, now when the object is kept beyond C, students, then the image will form between F and C. Right? This is the second situation. And in the third case, students, if the object is kept at center of curvature, right? Say guys, object is directly kept at center of curvature for the concave mirror, you will expect image at the center of curvature only. Okay, students. But listen, guys, in the first case, the nature of image will be very small, inverted, and real. I repeat, the nature of image in the first case will be very, very, very small, inverted. That's why magnification will be negative. Here we will see that magnification comes out to be negative, and it simply indicates that the image formed will be inverted, or else we will write like this: magnification will be many times less than -1. And here also see guys, this is the object and this is the image. So image is again inverted. Therefore, in this case also, image will be inverted. But the size of the image relative to the previous case will be slightly lesser than the object. That's why we always take like this: magnification is less than -1. But the nature of image is real, inverted, and smaller one. Okay. Here also real, inverted, and very small. Okay, guys. Now, in the third situation, if you keep object directly at center of curvature, then image is also formed at center of curvature without any magnification. That means in the third case, okay, when object is kept at center of curvature, image forms at the center of curvature only. A dash is the image here, A is the object point, AB is the object, A dash B dash is the image. So magnification will be -1. Negative indicates that the magnification, that is the nature of the image, is inverted. Okay, students. In the third situation, when the object is kept at center of curvature, image also forms at center of curvature. Okay, guys. Now in the fourth case, when the object is kept between C and F, right? Then this is the object. You will be getting image beyond C like this. When object is between C and F, guys, then image is formed beyond C. Very, very, very important observation it is. And the nature of image is again here real, inverted, and magnified. We will write like this: it is real, inverted, and highly magnified. Not highly magnified, but a bigger one will come, right? Size of the image will be greater than size of the object. So you will write magnification like this: greater than -1. Okay. When the object is kept between center of curvature and focus. Okay, guys. Now, if you take when the object is kept at the focus, then you will be getting image at infinity. Listen, friends, you see the first ray diagram. In the first ray diagram, when object is at infinity, guys, image is formed at focus. And in this fifth situation, when the object is kept at focus, then image forms at infinity. This case also satisfies the idea of principle of reversibility. But listen, guys, in this case, the nature of image will be highly magnified. You will be getting enlarged image at infinity, bigger one. But whereas in the first case, students, right, you will be getting a smaller image when the object is at infinity. But here, when the object is at focus, you will be getting a very big image at infinity, right, students? And the sixth case, very important, and compared to first five situations, sixth case is totally different. Because guys, in the first five situations, the nature of the object is real inverted. But whereas in the sixth case, means when object is kept between focus and pole, then you will be getting virtual image, virtual erect and magnified enlarged, like the students. So this is the only case, right, where we can expect the virtual image formed by the concave mirror. Usually for concave mirror, right, you will be getting real and inverted as long as the object is kept beyond focal length. But when the object is kept between focal length and pole, in that case, you will be getting virtual enlarged image, right? In the sixth case, students, you will see magnification comes out to be +1 or not +1, guys. It is many times greater than +1. Like this, you will be getting enlarged image will come, right? In the first five cases, magnification will be negative, and this is only case where you will expect magnification positive. This tabular form, students, will help you in understanding the nature of image formed by concave mirror, like in brief, easily, students. See, when the object is kept at infinity, image position will be at focus, highly diminished, real and inverted. And beyond C, guys, between F and C, diminished and real and inverted. At center of curvature equal to size of object, real and inverted. And here between C and F, beyond C, enlarged, magnified one, real and inverted. Highly enlarged. Here it is again enlarged. So listen, students. In the first five cases, we will observe that magnification is negative, but only this is a case where magnification will be positive. Very important observation here, right? M stands for magnification. Therefore, guys, if you focus on the image found by the concave mirror, definitely we will come across one of these six different situations, right? But if you take image formed for the convex mirror, students, you'll be having only two cases for the convex mirror. In that first case is object at infinity, second case is object anywhere between infinity and pole, right? Anywhere between infinity and pole, or else we can say this case as in front of the mirror, right? So now when the object is kept at infinity, you will be getting a image at focus like this, guys, right? And the nature of image is always virtual and erect, right? And when the object is kept in front of the mirror, then you will be getting image between focus and pole. See, guys, this is the image and this is object, and this is object at infinity, and here you will get the image. That means, see, guys, here this is the image and here this is the image. B dash is the image. Okay, guys, so always you never expect, okay, for real object, guys, you never expect a real image in case of convex mirror. For convex mirror, all the time you will be getting virtual and erect image as long as the object is real. Okay, students. So in concave mirror, you will be having six different cases, but whereas in the convex mirror, you will be having only two different cases. In concave, you will be having six different cases, students, that we understood with the help of this table. And here you'll be having only two cases, that is when object is kept at infinity and object is kept anywhere between infinity and the pole of the mirror. All the time you will be getting image between pole and focus, and the nature is virtual and erect and diminished. Here highly diminished, almost point size. Understood, guys? For concave mirror, you are having 6 different positions, but whereas for convex mirror, you are having only 2 different positions. And now see guys, if you focus on the ray diagram, we have used the ray diagram, we have used the rules for ray diagram. Like in the starting of this session, we have studied 4 different rules, no? So the ray diagram followed the same rules as it is.